So I'm at the Answers in Genesis Creation Museum, and I have Andrew Snelling with me. Thank you, Andrew, for doing this interview. Appreciate it very much. Tell us a little bit about your work history and also your education.
Well, I was born and raised in Sydney, Australia, and I attended the University of New South Wales as a geology student, graduated with a geology degree. Then I went on to the University of Sydney, also in Sydney, where I studied for a PhD, doing research on the mineralogy and geochemistry of uranium deposit in Northern Australia. And subsequent to that, I was working with two mining companies based in Darwin in Northern Australia, responsible for mineral exploration across Northern Australia, also with a mining project and research projects associated with both exploration and with the mining project. And then 30 years ago, I left the mining industry to move to Brisbane, Australia, to start work with Ken Ham at what was the forerunner to Answers in Genesis. I worked for 3 years with Ken before we exported him to the US. And so I've been involved in creation ministry now for nearly 30 years. And my responsibilities have been, of course, speaking, but doing research, writing, lay level, technical level material. I had a 9-year stint working with the Institute for Creation Research. I was still based in Australia for family reasons, and then just over 6 years ago I rejoined Answers in Genesis as the Director of Research, but still also a geologist on staff to do speaking, to do writing, to do research, to have input into the museum, to the art project, all those areas where it involves geology.
And so how many years were you in the secular world doing geology?
I was 4.5 years working with mining companies, although I had experience prior to that. During summer vacations from university, I was involved in with work for mining companies. So I've had all up some like 6 or 7 years in the secular mining world.
So as a geologist, as a creation geologist, you believe in Noah and the flood.
Correct.
And of course, we also have evidence from Mount St. Helens that there is stratification as a result of catastrophe. Do secular geologists deny that there is stratification as a result of catastrophe?
No, they don't. I mean, they do recognise catastrophes, increasingly so in the last few decades, because they talk about mass extinctions in the fossil record. They talk about meteorite impacts. And so they do accept catastrophism and they do accept catastrophic processes.
And that's
but they don't accept it on a global scale.
Okay. And that's actually somewhat recent, isn't it, with Derek Ager?
Yes,
really began
he and others question it, but it goes a number of different people, like with the meteorite impact issue, with rapid volcanism, with huge volumes of lava flows that are found in various places in the world require catastrophic action. And so it's been increasingly acceptable, but they don't give up the millions of years. They want to put the millions of years between all the layers. You know, a local catastrophe here, a local catastrophe there. But the one thing they won't accept is a global catastrophe, because that might mean the Bible is true.
And that's what I want to talk about. So do you have conversations with some of these, whether they're secular or atheistic geologists?
Occasionally,
and
yes.
This whole issue of the geology of the earth and talking about evidences and how it strongly reflects a global flood.
Yeah, occasionally I do. In fact, the most recent episode was last year, where I actually was in a debate, an informal debate at the Evangelical Theological Society in Milwaukee, where we had an afternoon session where I was interacting with an old earth Christian geologist, a professor from Mississippi State University. And so it was a question of pointing out the evidences that show that there was a global flood. Undeniable evidences straight out of the geological literature. But you know, this guy is prepared to accept some catastrophism, but he's not prepared to give up the millions of years.
Now, you were a major component of the RATE project. Would you describe for us what the RATE project is?
Yeah, RATE stands for radioisotopes in the age of the Earth. It was an attempt by a group of young Earth creationist scientists instigated by ICR, Institute for Creation Research, but also with cooperation from the Creation Research Society, to look into the issue of the use of radioisotopes to date rocks. And one thing was, first of all, one thing had to be established. Was it just that these were geochemical ratios that are found in rocks, or was there actual physical evidence that a lot of nuclear decay had occurred? And a number of areas indicate that. Byproducts of radioactive decay include helium. Also, the particles that are given off cause damage, so you get fission tracks and radio halos. In other words, this is observable physical evidence in the rocks, or measurable, that nuclear decay has occurred. And the first thing we established was that there was a lot of evidence for a lot of nuclear decay in the rock record.
Now, are you talking about accelerated nuclear decay
well,
at this point?
This is the second part of the research project.
Oh, okay.
Because if there has been a lot of nuclear decay, then within the biblical timescale, there had to have been events where nuclear decay had to be accelerated. I mean, if you find 600 million years worth of radioactive decay, products of that decay, but that is at the current rate of decay, 600 million years worth at the present rate. But in rocks that formed over 1 year during the flood, that means 600 million years worth of radioactive decay, as we measure it today, must have occurred in that period. That means that as it occurs to today is wrong, that it was actually faster back then. So what today would be 600 million years worth of nuclear decay occurred in 1 calendar year, Noah's flood. And so that was a major component of the research, looking at the evidence for that. And we found a number of lines of evidence that favoured that nuclear decay rates had been accelerated, for example, during the flood.
Okay. So one of those pieces of evidence you were talking about, fission tracks.
Correct.
Did I pronounce it correctly?
That's right.
Fission tracks. Okay.
Fission is where the uranium atom splits. It's what we get in a chain reaction that produces a nuclear explosion. And you have the two halves of the atom fly apart, and because they're so large, they damage the crystal, and we can actually see these tracks or trails where the particles have damaged the crystals. And so each atom that decays leaves one track. You count the number of tracks. If you know how fast it splits apart, then you can calculate how old the rock was back to the time before the tracks started splitting apart. And so you can go to the bottom of the Grand Canyon, a volcanic rock down near the bottom of the Grand Canyon, interlayered with fossil-bearing rock that is supposedly 500 million years old, and it has up to 500 million years worth of these fission tracks at the present rate of fission. But of course, these fossil deposits were formed during the flood year, and so that means you had to have accelerated nuclear decay. So that was one line of evidence that we found.
So from an evolutionary point of view, they would look at the same fission tracks and they would say, well, this is evidence of evolution, that this layer took place over millions of years. Is that what they would say?
They would say that the rocks were formed over millions of years. The current rate of decay of fission is much slower, and therefore it would have taken millions of years to accumulate all those fission tracks. In other words, they're assuming the constancy of the rate of decay. But of course, they weren't back there for millions of years ago to measure the decay rate. They weren't there in between times to check that it always stayed the same. So it's just an assumption that's unprovable, because you can't go back and check it. You've only got what's happening today to check.
Well, do you have some of your peers then responding to you about fission tracks as evidence for rapid decay? How do they respond to you?
Well, they respond by saying they still believe the millions of years, they still believe the constant rate of decay. They argue, well, how could you get nuclear decay rates speeding up? What about the heat given off by the accelerated nuclear decay? You know, those sorts of issues, and we can respond to those. And it all stems to an initial underlying belief. I mean, they accuse us of having a belief in Noah's flood, but they refuse to acknowledge that they are believing in the constancy of nuclear decay rates when so many other things do not remain constant.
Okay. Let's go ahead and talk about some of those things. So one of the big negatives to rapid increase in decay would be a great deal of heat. Go ahead and talk about that. How could that have been diffused?
Well, here's the interesting thing. Both the fission tracks and the radio halos, experiments have been done to show that if you heat a rock, the damage in the crystal repairs itself. and it obliterates the damage. It obliterates the radio halo, it obliterates the trap. So, for example, in Los Alamos, they had a drill hole at Fenton Hill, the same one that we used for the helium research in the RAPE project. As you go down, you go through a granite, and the radio halos are quite evident, but the in situ temperature of the rock increases as you go down in depth. When you get to 150 degrees Celsius, the radio halos fade and disappear. In other words, they're annealed because the little particles, like little bullets that have damaged the crystal the heat has energized the crystal, and so the particles of the crystalline structure has repaired itself.
Mm-hmm.
Okay, why is that relevant to the issue? Well, if there'd been too much heat given off, then it would have obliterated all those radio halos. We wouldn't have the radio halo evidence. We wouldn't have the fission tracks. So I would argue that, and the interesting thing is, at the same time, the radio halos, for example, are evidence of rapid nuclear decay. And if there'd been a lot of heat given off, the radio halos would have been obliterated.
So there is no way to actually determine how much heat would be given off?
Correct. The fact that the halos still are there indicates there hasn't been the amount of heat. Then we've got the issue of the water that was on the flood, on the Earth at the time of the flood.
Right.
That would also shield Noah and the animals in the ark. I mean, if you've got a mile of water, we use water in a nuclear reactor to protect and to
Very good
contain
point.
things.
Right.
And so that would not only shield from radiation, but it also would take up a lot of the heat.
And
there's a lot of evidence that at the breaking up of the fountains of the Great Deep, that involved supersonic steam jets that would have taken a lot of heat directly out into space. And so we have ways that we can respond to these sorts of criticisms.
Okay. Another source of evidence that came out of the RAPE project has to do with helium. I'm very fascinated by helium, so go ahead and explain that.
Yeah, well, when uranium decays, it goes through a series of steps in the process. From a large uranium-238 atom, 238 reflects as the number of particles in the nucleus, down to lead-206. And there's different steps, and at 8 of those steps, a byproduct is a helium atom. Basically, an alpha particle is 2 neutrons and 2 protons. It picks up stray electrons and forms helium. So if you do a mass balance chemical equation for uranium decaying to lead, you would produce, for every uranium atom that decays, you'd produce 8 helium atoms. Now, that means if you've got uranium, for example, atoms inside a zircon crystal, zirconium silicate, it's common because zirconium and uranium have a similar atomic size, and so some uranium atoms actually fit into the crystalline structure of zircon. So every time a uranium atom decays, it eventually produces 8 helium atoms. They're sitting around inside the zircon crystal. They're small atoms. They can slip between the crystalline structure of the zircon grains, and they should eventually leak out.
Now, I think that that's a critical issue, what you just said, that aren't they really tiny atoms?
Yeah, they're tiny.
That they're
and
just
also,
like balloons, you know.
They have no ionic charge. They're zero charge balance. They have no affinity to connect with any other atoms, so that they're chemically inert, so they have no reason to hang around. And so in the RAPE project, as a way of looking at this, you know, if we had a lot of accelerated nuclear decay, there would have, over a quick period, short period, only recently, say 4,300 years ago or so during the flood, then a lot of the helium would still be in those crystals. It wouldn't have had time to escape. And so at Fenton Hill, near Los Alamos, there was a drill hole that had been put down. I referred to it a minute ago. And we could collect samples. In fact, it had been done by Bob Gentry, a creation scientist in the 80s.
Yes.
He'd looked at zircon crystals at different depths, and he'd found a lot of the helium was still in those crystals. And that was a clue. And we asked ourselves, well, hang on a minute, has anyone actually measured how quickly helium slips out of these zircon crystals? And at that stage, the answer was no. And we looked at it and thought, well, okay, if these crystals are, as claimed in the secular literature, 1.5 billion years old, there ought to be so much helium in the crystals, and if they were 1.5 billion years old, then a lot of the helium should have slipped out. Whereas
so there should be very, very,
very
little, if nothing.
That's right. But if it was only 4,500 years or 6,000 years back to creation when the process started, and there was a rapid event during the flood, most of the helium should still be there.
Mm-hmm.
And so we made predictions before the crystals were sent away for analysis. And there was 100,000, 5 orders of magnitude difference in the two predictions. And so when we got the data back from the lab was given the samples blind, and when the data came back, it plotted the leakage rate of the zircon crystals was very rapid, and the data points lined up exactly with our prediction for rapid decay, 6,000, and the crystals being only 6,000 years old. In other words, a 1.5 billion years of decay had occurred at some time in 6,000 years. And most of the helium was still there because it hadn't had time to slip out. I might add, and it's important, the same laboratory at the same time was doing its own measurements on its own samples from other places in the US and got exactly the same results for the leakage rate of helium. So it was nothing about us rigging the data. It went to a secular laboratory, blind, and we made these predictions and we published them before we even sent them. I mean, so we could have been horribly embarrassed.
I see.
And Dr. Ross Humphreys was the principal investigator, and
Okay.
we went out on a limb on that. And lo and behold, the data, I mean, when you got predictions that are 5 order magnitudes apart, and the results came smack on our prediction, I mean, you've got to be impressed that that's meaning something.
Okay, so for regular people, again, just what the evidence really points to was that in the rocks there should have been much more. If the Earth was old, billions of years old,
There would have been time for all that helium to leak away.
It would have, right, I have it backwards. So right, there would have been almost no helium in the rocks.
There was evidence of 1.5 billion years worth at the present decay rates of helium, but it was still in the rock because over 1.5 billion years it should have decayed away. In fact, it was only 6,000 years of leakage that we could find, which the leakage age therefore is 6,000 years, which is a far more reliable estimation of the age of the rock rather than the decay rate. And it indicates the decay rate had accelerated.
The other side of it is there was is the amount of helium that's in the atmosphere. That if it had been decaying for these billions of years, there would have been way more helium in the atmosphere.
That's the other side of the equation, Jim, because once the helium leaks out of the crystals and out of the rocks, it eventually finds its way into the atmosphere. And if the atmosphere is, say, 3 billion years old or more, as the evolutionists claim,
right.
If it doesn't escape into space, and the evidence indicates that it's too heavy for it to reach escape velocity, if it does, very little escapes. And we've actually been able to measure these things. I mean, you measure how much helium is in the atmosphere, you can measure how much is being lost, you can measure how much is coming into the atmosphere. And Larry Vardaman did the calculations and showed that the present amount of helium in the atmosphere would get there in less than 2 million years, starting from 0 helium. And of course, that's assuming that the rate has been constant over time, which again, if it's not been constant, then that telescopes down that age estimate for the age of the atmosphere. So whichever way you look at it, the helium is a big problem to the millions of years evolutionary timescale.
Now, another part of the research dealt with carbon in coal and in diamonds. And also, if you could couple the answer along with the whole notion of many people still confuse radiocarbon dating with radiometric dating.
Yeah, well,
could you
yeah,
differentiate
sure.
that
Yeah.
and then talk about carbon?
Well,
in
radiometric dating, when we talk about radiometric dating, we're talking about things like uranium to lead, potassium to argon. And these are, at the present moment, time, measured as slow decayers that indicate, that have long age decay. But on the other hand, carbon is not present in most rocks, whereas potassium and uranium is. So you don't date rocks with carbon if there's no carbon in them.
So carbon could be in rocks.
Oh yeah, it's in fossils, for example, and it's in limestones.
Right.
But the point is, carbon decays so rapidly. To make it simple, if every atom of the Earth was made up of radiocarbon, it would all decay within 1 million years. And so if the rocks and the fossils were really millions of years old, there'd be no radiocarbon left, which is why they don't use radiocarbon to date dinosaur bones or coal or oil. But the intriguing thing, Jim, was that we'd noticed in the literature, and I'd noticed this back in the 90s, I was sending fossil wood samples off to radiocarbon labs as well, because the fossil wood clearly had carbon in it still. And we were routinely seeing that radiocarbon was present in those fossils. And it was being documented in the radiocarbon literature. The journal Radiocarbon had tens of these results that the scientists were ignoring. And we said, okay, let's put that to the test. So during the RATE project, we got 10 coal samples from the data storage place that the US Department of Energy uses at Penn State University. Yeah?
Your Australian accent.
Okay.
It's 10 coal samples.
That's right, C-O-A-L.
Okay, I'm
10
sorry.
of them. No, that's fine. It's the deep southern accent. Yeah, and so this is the US Department of Energy has every mining company, every coal mine, they get samples and they seal them in a special argon atmosphere to preserve them, and they're available for research. So we asked for 10 samples from 10 different coal deposits around the US, aged from over 300 million years to around 40 million years in the evolutionary time frame, sent them off for radiocarbon, and they all had the same amount of radiocarbon. In other words, they all gave the same radiocarbon age, when they were, which was only thousands of years, compared with ages of over 300 million years to 40 million years. Well, that's what immediately told us, well, that makes sense. During the flood buried pre-flood vegetation all at the same time, so it should have the same radiocarbon age, and it did. And secondly, because it had radiocarbon in it, it couldn't have been millions of years old. It only had to be thousands of years old. Now people say, oh, contamination. Hang on a minute. The scientists have done their own measurements and they have reported it's not contamination. You put in a blank sample holder and you get zero result. It's not laboratory contamination. It's not handling contamination, because they hit the samples with hot, strong acids and alkalis, and then another wash with strong acids. I mean, they just kill everything that could possibly be contamination during the preparation process. So this is not contamination. These are real results that are repeatable on coal, oil, limestones, on dinosaur bones, fossil wood, fossil shells. It's all there in the literature, and it's being ignored, that these things are only thousands of years old.
Wow. So there it is. The evidence is being ignored from the evolutionary point of view. It doesn't fit their time scale, doesn't
Correct.
fit their worldview. And now you are published in a variety of secular journals as well as creation journals. How are some of these people responding to what you're saying, maybe in the secular journals? Are they...
Well, for a long period of time, they ignored it. The main thing that's happened is that there have been blogs and different comments on websites. But the interesting thing is those aren't peer-reviewed. And I've seen a number of those, and unfortunately, what happens is when emotions take sway over and beliefs are at stake, people get irrational, they get emotional, and they say silly things.
Right.
And a lot of these blog sites are actually making ridiculous accusations that are easily refuted.
Okay.
And have been refuted repeatedly. For example, with the helium work, Russ Humphries has repeatedly responded, and they keep on repeating the same accusations, and he repeats the responses.
Right, yeah.
And so it's like what happened with the radio halos evidence back in the 1980s at the Arkansas trial. Back when Robert Gentry was on the witness stand and presented the radio halos. In response, the American Civil Liberties Union put up G. Brent Dalrymple, and all his response was, it's a tiny mystery. In other words, he wanted to ignore it. He wouldn't engage the evidence, he just ignored it so it would go away. And that's typically the reaction we get.
Okay, excellent. Dr. Snelling, thank you so much for doing this interview with us, taking the time to do this. This is really critical information to help people understand some of these basics about dating rocks, dating what's going on and with the carbon and diamonds. I mean, there shouldn't be any carbon in those diamonds,
That's right,
and yet,
exactly.
and yet it has been
An
discovered.
interesting thing, Jim, that work was repeated by University of California, Riverside scientists. They did their own radiocarbon tests of diamond and replicated our results.
Thank you for being part of that project too.
It's a pleasure.
Thank you for all those people that contributed to that
Absolutely,
project.
to make it happen.
Yes.
You're right.
Good. Thank you.
Thank you.